I11 into, let's say, omega 1 square plus 2 times I12 into omega 1 omega 2 plus etc. So, terms involving only one of the frequencies and terms involving two frequencies will be present in this particular expression. Okay? Whereas now look at the front. So here, once you have this one, okay, you can find the inverse of that one. S inverse is nothing but S transpose. Okay? And I said, once you do that exercise, this becomes diagonal, you get some real numbers. Let us call this S transpose omega as some omega prime. S transpose omega is like this particular transpose of this matrix multiplied by omega 1 omega 2. So it is some new omega, rotated omega. Omega is a vector, so S transpose omega will be basically some S transpose. So because S is a rotation matrix, okay, it's an orthogonal matrix, it's a rotational matrix. So action of S on any vector is going to be rotated. So if you call this one as omega prime, then you can say this is equal to omega prime transpose diagonal and inverted. That means omega prime 1, omega prime 2, omega prime 3 into I1 0 0 0 I2 0. This one into. So this expression will come to this. Do you understand that? So this is becoming simply naive. Omega prime squared plus I2 times omega prime 2 squared, omega prime 1 squared, I2 times omega prime 2 squared. So there are no cross terms here. Now this expression for the kinetic energy becomes very simple. So here what we are doing is, even though we started originally with some set of axes here, you see like x prime, y prime, z prime here, you can have some new sets of axes here. These are called the principal axes here. So when we look at the moment of inertia with respect to this axis system here, you find that these two things are probably not equal to zero. But as soon as you do the calculation with this coordinate system, you find all the off-diagonal terms have become zero, only diagonal entries are. So the similarity transformation that we are doing here is discovering a coordinate system in which the off-diagonal elements of the moment of inertia tensor identically becomes zero. That is great simplification.
Does that represent any direction? Does that represent any particular direction?
Yeah, they represent definitely particular directions. That's what I said. This is one orientation. Because you, in the beginning, you do not know whether one particular coordinate system is superior to another one or not. In principle, the rigid body can be described by any coordinate system of your choice. Keep one point in the rigid body fixed, arbitrarily take one direction as x, then another one as y, and consistent with that one, you automatically get the third direction. You can jolly well describe your system with that one. The only thing is, when you look at the moment of inertia, it will not be in general diagonal. It may have some off-diagonal elements. So much so that the kinetic energy will have terms involving two frequencies at a time. Whereas, with that one as the base here now, because you know now what are the moment of inertia coefficients, now you ask, okay, let me diagonalize this one. Means we are looking for a new coordinate system in which off-diagonal terms are zero. So in that case, the moment of inertia tensor becomes very simple like this. So we go from this one to 1 half summation over ij omega j square into principal axis. That is the greatest simplification that you can immediately see. Okay? Analysis becomes now relevant. So you go from quantity which is having all sorts of terms here. Your equations of motion will become very complicated. Instead of that, you get simple equations of motion if you use the principal axis.
Suppose I find the eigenvalue is 5, I1, I2, I2. Then without worrying about that S matrix, without constructing that, can I simply write it this one?
The point here is now, okay, that's why actually I wrote that expression here.
To get omega prime I need S.
No. These are the angular frequencies. So far the kinetic energy involves only the angular frequencies. Whether we start with the original omega or this transformed omega, they are all still linear combinations of the frequencies only. But what is the aim of dynamics? You have to know everything about the orientation of the rigid body. Orientation of the rigid body was specified by these Euler angles. So you have to go one step further and relate these omegas to the Euler angle also. Correct? What are the Euler angles? What are the angular frequencies? It will be described in terms of theta dot, phi dot, and psi dot in general. Because we have three rotations here, three Euler rotations, phi, theta, and psi here. So when you want to change the rate of change of the angle, it will involve theta dot, phi dot, and psi dot. What means these omegas are basically linear combinations of phi dot, theta dot, and psi dot. So if we arbitrarily choose some other reference system and get omega here, they will not match with the definition of phi, psi, and theta. So we have to keep track of how are these new omegas related to the old omegas. And S matrix has to be there. Using that information, now we can work back and find out equations for phi, theta, psi. This omega is involving phi dot, theta dot, psi dot. They are the first order derivatives of phi, theta, psi. Our ultimate aim is to solve for phi, theta, psi. So you have to actually solve, for example, 6 equations. Omega 1, omega 2, omega 3. They are first order derivatives of phi, theta, psi. So if you integrate them, you obtain phi, theta, psi. So there are 6 unknowns in the problem when it comes to the second order differential equation. So we need to have a prescription for solving 6 equations simultaneously. But when I go to the next step, which I will do tomorrow, already it is getting late for you. Okay. But the first thing I will do is to get what is called the Euler equations. They will be equations which tells you essentially expressing d by dt of various omega j's. First order equation for omega will be obtained. It so happens that that equation will not be involved in phi, theta, psi for simple problems like the top and some of the tops it will involve, only for the free top it will not. So on the right hand side you will find the angle variables also. So to make connection between them, the first thing we have to express is to express omega j's in terms of these 3 angles, phi dot, theta dot, and psi. Omega j as a function of this one. This is what we do. That's why we need this matrix. So don't erase that one. We will use that tomorrow.
So what we have done here is we have found